Hey guys, this is going to be the first tutorial video I'm going to make in this series of videos. These videos are going to cover how to use a lot of software that you're going to be using for the 3D printer. There so that you can have a reference once you've completed the training, or if you want to have a better idea of how to use the software before going into the training session. They're going to be found on the website, and there'll be multiple of these, so keep an eye out for them. They'll be pretty useful. So the first thing we're going to go over is how to select the right printer. I'm working from home, so this is the printer that I have. The one in the lab is going to be slightly different though. The one we have in the lab is an original Prusa Mark III with a 0.4 nozzle. You'll be able to see it on the computer at the lab, so you don't have to worry much about that. You'll just have to select it the first time you log into it. The next thing we want to go over is the type of filament we use. You can change that by clicking on the filament tab and selecting the filament. Most of the time you guys are going to be using generic PLA. We don't really use PETG or ABS on the Prusa printer. We don't have enough well-trained people, and PETG and ABS tend to jam whenever you're changing from those materials to another material that has a lower melting temperature. So for now, we're going to stick to only using PLA, but that might change in the future. Another important setting is the quality. The quality will obviously change the quality of the print, but it's also going to change the speed that it takes to print the part. So I'm loading up a Benchy model just to demonstrate, and I selected the 0.25 millimeter draft quality setting, and once I slice it, it's going to be cut down into a bunch of tiny layers that the printer is going to run through, and you can see through these layers with this little tab. Pretty cool. And basically you'll get an estimate of how long the print time is going to take. This one's going to take about an hour 13 minutes, give or take. It might be a little bit more or it might be less. Depends on some settings that you can change on the printer, but I'd say probably more based off of experience. If I turn the quality up, however, notice how much more detail there is. The lines are thinner, so you have more lines per distance that the printer goes vertically, so you're gonna get a lot more detail. It's gonna look a lot nicer, but since you gotta cover more ground, it's gonna take up more material, and it's gonna take a longer time. It's gonna be about an hour 56 minutes. That's almost 40 minutes more than the last quality setting. And if you go into ultra high detail, it should take about 7 hours 30 minutes, if you can see. But it's got some crazy good detail, as you guys can see. You can barely even see the layers sometimes. But yeah, so keep in mind that good quality is going to have a trade-off for how long it takes to print. And the longer a part takes to print, the more likely it is to fail, because there's more time for things to go wrong, or for someone to mess around with a printer and accidentally ruin your print. So I'd recommend staying around the 0.15 quality print. Usually you don't need anything more detailed unless you're doing some really tight tolerances. Next thing we want to go over is the infill settings. So I'm switching over to 0.15 because it's easier to render. And right here is the infill settings. So I can choose how much infill. What infill is how much plastic is inside the model, because the model's not made up of 100% plastic. It's got a lot of air inside of it. So this is 15%. But if I change it to 50 and slice it again, you can see there's a lot more plastic in there. The structure is tighter. There's a lot less air. It's going to make the print a lot stronger, but heavier, and it's also going to increase the time. It went up from an hour 30 minutes, an hour 50 minutes, I mean, to almost 2 hours and 30 minutes. So it's going to be another trade-off that you'll have to keep in mind. Please never go 100%. You'll never need to go. I'd say you don't ever need to go over 50, and you'd rarely need to go 50. If you need something really, really strong, ask an officer, and we'll print the part with the newer printer we have with the nicer materials. But don't go over 50. I wouldn't recommend it. Okay, next thing we want to go over is some more advanced settings. Right here, you can change the layer height, which is the same as the quality. Not really a need to change it in here. You can always just select it either here or back at the plate where we talked about earlier. Vertical shells will change the amount of perimeters around the print. So if you can see right here, 2 layers. See these two? If I change the setting to 4 and then slice the print, 1, 2, 3, 4. So this will also help make the print stronger, but it's also going to increase the time. It's at 2 hours and 34 minutes. So that's something to keep in mind. You usually don't want to mess with it unless you really need to. And there's rarely a need, but BattleBots people might have more of a use for it. This does the same thing as the perimeters, just horizontally. So the bottom of the print will have more layers. We really don't use that often. Usually when we mess with the perimeters, it's for the vertical perimeters. Right. Infill, you change the infill here. You can change the type of infill. Right now we have gyroid, which is this funky stuff. But I can change it to, let's say, honeycomb. This is normal honeycomb. And if I slice it, as you can see, changes the type of infill. Usually not a lot of point to it. There are some cases that you want specific types of infills, but I think Will's gonna go over them in the CAD tutorials, or at least not the tutorials, the training session. So don't worry about it for now. You don't really mess around with this. Support material, I'd stay away from it if possible. Usually you want to stay as far away from support as possible because it is a pain to take off the print. Sometimes it'll take longer to clean the print from the support material than it does to print the entire thing. I'd orient stuff correctly. That way you can avoid having too many overhangs and nasty corners that are floating in the air. You don't want that. But in case that you do need support, you just select it, slice, and the support's this green stuff that appears. Yeah, not the most fun stuff to clean, especially in these little corners. So I'd stay away from it if possible. And we go into the filament settings. You can change the tolerances. Usually first layer temperatures are a little bit hotter than the normal temperatures just because you want better bed adhesion, but we'll talk about bed adhesion in another tutorial. So really I wouldn't mess around with this unless an officer tells you to. Some types of special filaments do have different printing temperatures than this. So, and there's really nothing else that you guys need to worry about. We don't modify the E-Club printer, so just stay away from it. And we don't want to mess around with retraction unless we start printing PETG, but we'll cross that bridge if we get there. Okay, the last couple of things we want to go over is how to import files. I kind of rushed over it. You go File, Import, and you get to choose between these files. The most common ones are STL and OBJ, but it's mostly STLs. And you just find it in your File Explorer and import it. It's pretty easy, like I said. You can click and drag it, or if you're fancy and stuff, you can use these axis. You can also change the scale. But if you want to change scales, I would recommend using the CAD software you designed the part with instead of this, because it'll be a lot more accurate. You can rotate it if I can get a hold of it, and you can put it on different surfaces. This is probably the most used tool you'll have, because you can use this to select the right surface to put the part on. So if we want to avoid support material, this is not a good spot. We want it to be at the bottom where there's arches that'll support themselves. And then finally, one of the most convenient tools is the arrange tool. And if you click on it, it's going to arrange the part. But it's really the most useful when you're printing multiple parts. So let's say I got the normal benchy, and then you got another one. Let's say we got 3 of them, and we got one in these 3 corners over here. There it is. So the printer is going to run through the layers and do the first layer here. It's going to go over here, first layer there, move over here, first layer. So this transition time between the 3 points is going to take a long time. Like, it'll add up. It'll look like a couple of seconds, but it's going to add some time to it. So if you want it to arrange as efficiently as possible, you click the arrange button and it'll fix it for you. Really useful if you're like mass producing parts for a competition or something. So this is a pretty useful tool to have in mind. And so the last thing we want to go over is preparing the file for the Prusa software and then the printer. So we just click slice, like I said. This is after you selected all your settings that you want. Oh, we don't want support usually, but since it's just an example. Once you slice the part and you inspect that everything's fine and up to your standards, you click export G-code and save it to your files. And then after that, you're going to open it in a Prusa software, which is going to be explained in the next tutorial. So go ahead and jump over to that one if you have time.